day to everyone. So my name is Yugendran and I am from Penang and I did my primary and secondary studies in this Penang and even my tertiary education is Penang. So my team is the Tomahawk Robo and I am the leader of the group. And this is
My name is Mohammad Umar and I am from Pakistan, and I did my high school in Pakistan, and I did my foundation from Nilai, and I'm doing my degree in this university in Penang. And this is my friend.
I'm Malcolm. I'm from Penang as well. I was raised in Penang, so my high school and primary school is from Penang, St. Xavier's. I did my tertiary education in ED International College Penang, and now I'm doing EUB.
okay. So we are the Tomahawks from this group, and the mission of our group. Why do we form this group? The main thing is we want to explore the NXT robot, how it works, and what are the applications. And another reason was this is a requirement of our university, so we formed the group. And now I'm first welcome to explain about our wiki page.
This is the wiki page we made using Google Sites. As you can see here, this is our homepage. We have described what our mission is and what the page will be about. This page is about the course we are currently taking. It's called robotics. The course description, learning outcome, and learning objectives are all described in this page. And as for this page, our details and pictures are all in this page. This is our course instructor, Mr. Ryan Chong. We have one page dedicated for him. And in this page is our assignment one, and when it starts and when it ends. And now I'll pass it to Imar.
I'm going to talk about the demo board building. These are the few steps that we took in class when we were studying our few first days, that how to do our demo board. The first thing is, first visualize it like this. We have to construct it by using different parts. For example, the motor, servo motor, and a few components that are given to us to construct our NXT robot. So these are all the parts, all the steps that we do to make the demo board. I'm going to talk about the labs now. These are the programs that we observed were given in our class, and we observed what happens when we program them. First program was, someone commented that the NXT robot cannot move in a straight line. So this is the first method that we use to check if it can move or not. So first program was simple program, just move the forward and then weights and off. These are the two videos for the first program. And the second program was the reg move. We try the reg moves for the method B. And for that method, it could move straight, but it cannot move but it's an imperfect straight. So for this, it doesn't move. It can move straight, but it's an imperfect straight. So the third program, we use the XPID method. In this method, when we tried and observed, and we saw that the robot can move straight in the forward direction and also can move straight in the reverse direction. And then after that, we had topic 2, which was NXT robot with team quiz. So in that program, we had 3 programs. First program was our touch sensor. We have to observe what happens when we use this program. So when we use this program, we observe that the robot moves forward, injects the signal, and moves reverse, and then stops. This was our observation. For the second program, this was the coding for the second program, and this was a simple program. It actually follows the black line. The threshold that we use was 50. it makes a circle, 360-degree turn, and the time for that was 2900 milliseconds. It's actually using a subroutine. First it turns and then waits and off. It's using a subroutine technique. And then we had lab 1 and lab 2. Lab 1 is a simple program, it just moves forwards. Lab 2 is a subroutine program, same program but using a subroutine technique. It says there's one subroutine that move. Lab 3 and lab 4. Lab 3 is a touch sensor program. And lab 4 is the same program but it's using a subroutine technique. It's called touch. To make it use this task first and then goes to the subroutine, same program. This is the video for that. Just the brain teaser 1. Brain teaser 1 is actually a combination of 3 and 4 lab. 3 and 4. First, we had move from third lab and the touch from the fourth lab. And then we combine and we have to observe what happens. We observe that it moves forward for a while and then after that when it touches the optical then it stops. This is the observation to that or brain teaser 1. So for this we have two cases. First case is number 1 that we just saw who touch. So for the second case, we had to observe what happens if we add another subroutine. Okay, this is a second method. We have to observe what happens if we put another subroutine at the end. Move. So what we observed was that it stops after a delay and when the rover hits the obstacle. Now 6. My friend will talk about the lab 6.
Okay. Lab 6. Okay. Lab 6 is about the usage of the break statement with the use with the use of the constant value. Okay. The purpose of lab 6 is to understand on how to use the until loop inside the while loop. And for this lab, we need to define a value for the light sensor to operate. The value is 45. And the problem is, the main problem was we don't know what is the value to be assigned to the threshold constant. So what we did was we used the NXT robots. One of the facilities is to measure the value of the reflected light. So we use the facility and then measure the value of the reflected light on the black surface and the white surface. So from that we make a conclusion that the value should be 45 and we include it inside. And the video of our observation. So the robot starts on the white surface and then stops on the black surface. And the next one is the next thing is slight modification in the lab 6 program. In this program, we have included the break statement. We want to study what is the use of the break statement. And when the break statement was used, the robot behaves in this manner. It takes a delay to stop after detecting the black surface. And the next lab is our lab 7, which incorporates the use of the subroutines for the same program which we were using in our lab 6. So we have used the lab 7. Sorry, we have used the substitution technique for the same program, and the problems encountered were if there is any mistake in the if there is any mistake in the coding in the alphabets, it will show this error, which is the line 7 constant or constant expression is the error of line 7 constant and constant expression is expected. This is because of the wrong coding of the set sensor. And the next lab is, and this is our video, and the next lab is our lab 8. The lab 8 is carried out to study on the use of variables in NXC, how to use them, how to define them in a proper manner. And this first line is the definition of the variables, and then these 3 lines are the assignment of the values for the variables, and the observation is as follows. Okay, the robot moves front and back for the 5 times, and the lab 8 program was modified, and for now we have included the while true loop to study the behavior of the NXT, and this is the video. Okay, the robot moves forth and back infinitely until we stop the robot.
This is our assignment for semester 1. The objective is to construct a robot that follow a certain requirements. The robot should follow a white line in a counterclockwise manner, detects the object, leaves the white line, and will move within the white perimeter formed by the circle randomly until a sound is heard. It plays the tune and then goes back to following the white line in a counterclockwise manner. Right now, I'll pass to Vijendran.
Okay, thank you. So the duration of our assignment is 1 week, exactly 1 week. It's from 23rd February until 2nd March. And 2nd March is our demonstration day. So now, okay, let us see the design of our robot. The design of our robot is named as simple base design. Why is that so? The simple base design was created because of the fundamental and basic arrangement or the assembly of our parts, the ultrasonic sensors, sound sensor, and others. And this is our gas track with your obstacle of the gas track. So the next is we're going to talk about the program. Okay, the program. Okay, let me start with the 5th line, which is the definition of the variables. The variables were defined for the task random, which is the move time and reverse time, and we have used 6 tasks. And the next one is the task line follow. Task and follow. Okay, for this task, we have defined the threshold height constant at the first line itself. So the value is still the same as the 45, and the thing is 45, and the thing is now we are using the touch track with black surface and white line. So we need to made some modifications in the if statements. So we made the we made the changes in the operators we use more than and equals to and less than. And the next task is the task locate object. This task is for the ultrasonic sensor of a robot to detect the object and to turn left, and then turn left and then move forward. And another one more thing, this is the main thing, exit 2 statements, exit 2 command. During our testing, the robot can only perform the first 2 tasks. The other tasks it cannot perform at all. So what was the problem? So when we do some research and troubleshooting, we found that we need to put a connectivity or continuity between the tasks. So we choose this execute command. Execute command, and we have applied it for the to the programs, to all the programs. And the next program is our task render, which is the same thing as our lab 8, but this time we need to include some new commands such as on forward commands and the wait commands, and the next task is the task instance sound. This task instance sound is for the sound sensor. The sound sensor needs to detect the sound produced, and then it should react accordingly. And then after this task, we need to. The next task is the task tune. For this task tune, we have used the play tune commands, and the notes were A, B, C, E, and F. A, B, C, and E, and F, and the last task was a task to find 9. What the main thing for this final task is the usage of the stop sound statement. When I searched on the internet, I found out that one of the ways to stop the tune from playing is to use this one, stop sound, and when I tried it, it works as I expected. And this is our task name with the basic statement inside. And now let me pass to.
I'm going to talk about the problems encountered and solutions in hardware, and also the problems encountered in the software. So first I'm going to talk about the hardware. So no problems were encountered during the assembly of hardware parts and along the long time that we searched for the parts that we were building or when we were building our demo board. The second part is the twisted wires for connecting the light sensors and the input port 3 causes the objects to fall sometimes because the wires are too long. So we use that rubber bands to tie the wires so that they don't affect the sensors and everything, so that it will move along the line. So in the second part is our software problems. The problems that we encountered in the software and the solution for that. First problem that we encountered was the ultrasonic sensor. It detects the object. Somewhere sometimes, but not always, because it was the value for the near constant. The near constant value was 10 centimeter. So the robot gets confused sometimes because the value was 10 centimeter and it was too less for the object for the robot to detect. So we changed the value from that to 20 centimeter. After that, changing the value was working fine. And the second problem, the robot performed only 2 tasks. It was just because we were using the proceed commands instead of the exit 2 command. You can see the exit 2 command there. First we were using the proceed. So the robot gets conflicted when we are using like proceed. They have conflicts between the commands. And then when we use the exit 2 command, after that the robot can perform the task because it knows to exit the command and go to the next command, which makes the robot less confused and perform the task easily. And the third one, the robot does not perform the task random, for it skips the task random and performs the next task. This is called because the definition of the variables were wrong. Solution for this was the variable inside the task we change the variables and inside the random task and change the values for that. We made the file from 50 to 500. And then after the robot finds fourth problem was after the robot finds the line and rejoins the white line, the tune does not stop because we weren't using the stop sound command. When we use the stop sound command in the program, it stopped playing the tune and the problem was solved because of we weren't using this stop sound command. When we use the stop sound command, it stopped. And these are the few errors that I faced while we were calling the program. And this is our final video for our assignment. This is the follow line follow command. Here you detect the object and move inside the line. This is the new random command. And now it hears the sound and go back to the line follow command. This is the task that we were assigned to. Finally, we finished our program by all these commands. Now I'm going to talk about the conclusion that what we have learned. So we have come to the end of our presentation, and I'm going to talk about what we have learned in this semester. So we have learned that to use the subroutine techniques. We have learned the proceed tasks also. We also have learned how to use different commands like execute command, like break command. We have also learned how to use the few commands like forward, wait, and few other commands. So these are the few things that we learned in this semester, and we are going to continue learning in the second sem. So this is the end of the presentation, and thank you very much.